This represents the world's first single-atom transistor made with absolutely perfect precision. It's the work of researchers at Australia's University of New South Wales, and it demonstrates all the potential for being the building block of a super-fast quantum computer, a device that will solve some of our grandest technological challenges.
The thing that's unique about the work that we've done is that we have, with atomic precision, positioned this individual atom within our device.
Single-atom devices aren't new, but the ones developed so far have a margin of error of around 10 nanometres. A tiny spatial shift, but enough to affect their overall functionality.
So this individual position is really important if you want to use it as a future quantum bit or qubit, because it turns out that if you want to have control, precise control at this level, you need to position the individual atoms with atomic precision with respect to control gates and electrodes.
And so several groups have tried this, and indeed they've been able to isolate a single atom in their device. But really, if you want to make a practical computer in the long term, you need to be able to put lots of individual atoms in. And there you find that the separation between the atoms is quite critical, so you need to have atomic precision to do that, and so that you can also bring electrodes in to address each of those individual atoms. So this is kind of the key step, making that first individual atom device, but in a technique that would allow you to scale it up to put lots of single atom devices in towards making essentially a full-scale computer in the long term.
The beauty of the UNSW device is that it's encased in silicon, a thoroughly researched material commonly used by industry. It opens up the possibilities for future manufacturing.
Anybody that deals with silicon quantum computation would be hard-pressed to go past Australian publications at this moment. So with Michelle's group over the last years, or last 5 years I'd say, definitely has established itself as a world leader in that field.
It's predicted that transistors will need to reach the single atom level by 2020 to keep pace with Moore's law, a trend that sees the number of transistors squeezed onto a circuit double every 18 months to 2 years.
So we really decided 10 years ago to start this program to try and make single atom devices, as fast as we could and try and beat that law. So here we are, I guess, 2012, and we've made a single atom transistor roughly about 8 to 10 years ahead of where industry is going to be.